In today's video, we're going to look at the concept of computer control and data logging. Here's an overview of hopefully what you will know or be able to do by the end of watching this. Now, when we talk about computers and computer control, we mean computers in the loosest sense of the word. Your home is filled with about 75 different computers on average. There are computers in your fridge, your microwave, your washing machine, and even your toaster. So, what is a control system? Well, a control system typically comprises a computer or processor, a control program which handles data from the sensors and sends signals to output devices, and also an interface box to convert signals between the sensor and the process. So here we have our sensors, and they send an analog signal to the interface, which then converts it to digital so that it can be processed by the computer, which then produces an output. Sensors. Sensors are an input device which can be used to measure almost any physical quantity. Different types of sensors measure different quantities. You can see here on the left hand side all of the different sensors. Here is what they measure, and here you will find typical examples of where they might be used at home or in other organisations or buildings you'll be familiar with. They monitor changes in environmental conditions. They work by recording external measurements in the surrounding environment and sending that data to the computer for processing. The recording and sending of the data can be set to happen instantaneously or stored over a period of time and then sent. If we look at an example of a greenhouse, possible sensors that you might find here might be a temperature sensor that measures the heat in the greenhouse, and if it's too warm or too cold, it turns on the fans, opens the windows, closes the windows. You may have an air humidity sensor, which tests the moisture in the air, and if it's too dry, it sprays water into the air. A soil moisture sensor, again, adds water if the soil is too dry. Or a light sensor, measures the light and controls the windows or the blinds and opens or closes them as appropriate. Data logging. Data logging is the automatic capture and storage of data without human intervention. And the two key things that you need to be familiar with or aware of in terms of data logging are the logging interval and the period of logging. Now, the difference between those, the interval between each recorded log is known as the logging interval. The period of logging is the length of time over which the data is logged. So in this example, our sensors will take a reading every 30 seconds, and it will do that for a period of 24 hours. So in this example here, you may have a sensor in the fish tank which will be set to record every 30 seconds and sends that data along here to the interface, which then sends it to the computer, and that's recorded every 30 seconds for 24 hours. Computer controlled systems are used to monitor and control conditions within a given environment. On the screen here you'll see some of the equipment that's necessary for a computer controlled system to work. You obviously need your computer, the analog to digital converter, sensors, cables to run from the sensor to the computer and the converter, and your data logging software installed on the computer. Control systems at home. Well, there's quite probably a lot of control systems that you have within your own home, but some examples that you will be familiar with could be security sensors to control external lights, controlling devices over the internet, like turning your lights off remotely using your mobile phone, taps operated by infrared beam. I'm sure you've all seen them. You just place your hand underneath the tap and it starts to run. Underfloor heating. Automatic blinds, automatic lights. Those are examples that you should be familiar with. There are plenty of other examples, so I suggest you do some research and find them out. Another example you should all be familiar with are the traffic speed cameras. I'm sure you've all seen these dreaded cameras on the road when you're out driving with your mum or dad. And the way these cameras work, they contain a video system with automatic number plate reading. Then you need to have 2 sets of cameras fitted with the infrared sensors. And it works out the vehicle's average speed given the time it takes to drive between 2 different camera locations. In a hospital, there'd be many different control systems. Some examples might be MRI machines, blood pressure monitors, heart monitors, oxygen monitors, machines that measure and regulate the amount of drugs that you get, robots that perform surgery, ambulance control systems. Again, there are plenty of others, so think about other examples that you could use if you were required to in the exam. Feedback. Feedback is a key component of any control system. We have here our input, which will be a sensor. We have here then the processing, and we have here our output. In this system, the input is processed, and action happens as a result of that processing. Then this is sent via a feedback, and the whole system starts all over again. We're going to look at an example of that on our next page here. So, a typical central heating system. A sensor up here might record the temperature outside. So, say the temperature reaches 2 degrees. All of that data is passed along here. Signal sent to the processor, and the ADC converts it from analog to digital. The computer then instructs the central heating system to turn on so that it warms the house. Likewise, an internal sensor will measure and send back data about the temperature inside, and when it reaches a certain level, say 20 degrees, the heating will be turned off, and this cycle will run continuously. Now, here are some problems with manual methods, and manual methods are readings taken by humans. Just be aware of what the problems could be. And a lot of it's to do with accuracy, frequency, getting tired, recording the data for long periods of time, and then obviously recording in dangerous areas near volcanoes, earthquake zones, etc. So here's the advantages of using automatic data logging and control. It can be recorded 24/7. The frequency is unlimited, so you can take it once a second. It's highly accurate, so the computer will always take an accurate result. Again, if there's any danger, send the robot in to do it. No time delay, so it can be happened, as we mentioned earlier on, it can happen straight away, or it can be stored up. And you can import the packages into other things like spreadsheets and word processing for analysis or reports. Finally, some key terms that you need to be familiar with: data logging, feedback, and sensor. Make sure that you know a good definition of what each of these are.